This is the third section of chapter 1 on transportation problems, and in this section we'll be looking at finding an improved solution. So the previous sections where we've gone through the northwest corner method, this gives us an initial solution, and this section is all about improving on that initial solution. So when we use a northwest corner method, we need to remind ourselves, remember and check whether our matrix is balanced or not, a problem is balanced or unbalanced, we'll need a dummy, or whether it's degenerate or not, and then we'll check the number of cells used against n plus m minus 1. So the algorithm for finding an improved solution after you've used our northwest corner method, our initial solution, involves 3 steps. 2 of the steps we're going to go through in this video, and the last step we'll go through in the next section video. So what are the steps? We're going to use the non-empty cells to find the shadow cost. Now costs are made up of costs from the source and costs from the destination, and we start by making the first source cost equal to 0, and then we solve the resulting equations. You'll see this all when we do an example. I'll go through it nice and slowly so you can see what's going on. And we write this as the source cost at A. So if A was the first source, then we'd write the source cost at A is equal to 0, and we solve the resultant equations. And the second part is using the shadow costs, which we calculate here, and the empty cells to find what we call the improvement indices. So if you've got a cell that has P as the heading in the column and Q in the row, so we're talking about going from P to Q, from source to destination, and we write this an improvement index, we write as IPQ. Well, this is made up of the actual cost of transporting from P to Q, and we subtract these shadow costs which we've calculated in this previous part. Again, I'll go through all of this. Then the next part is using these improvement indices and the stepping stone method to find an improved solution. So next section we'll go through this stepping stone method. So by the time we get to the end of this video, we'll be 2/3 of the way through of finding an improved solution, and then once we've done all 3 steps, we sort of loop around these steps and iterate these steps until we found an optimal solution. Example 6. Calculate the shadow costs given by the initial solution to the problem given example 2 shown in the table below. So I'm not going to go through the northwest corner method again. So I'm just going to write down what the result of doing that algorithm was on this table. If you need to do it again, you can have a look back at example 2. So this is the result of that example here. Now this part of the algorithm, the shadow cost, now just involves the cost. So what we're going to do in this table is we're going to put in what the costs were for the cells that we've used. So this shadow costs involves starting by writing in the costs in these cells that we've used, and actually we don't need the demand or stock. So rather than just do another table, I'm just going to use this table here. So 11 here relates to this cost here, so I'll highlight them. So the 11 relates to this cost of 180, the 3 relates to this cost of 110, the 12 250, the 4 150, and then the 2 10s here and here. And I'm going to replace these values here with those numbers. So I'll just rub those out. You would probably draw a FEST table or have a table to use. So 180, 110, 250, 150, 190, 120. Okay, so that's the first step. It's just the cells that you've used in a northwest corner method, replace the cells, the numbers in those cells, with the costs. Right, now we're going to take this information from this table and we're going to add a first row and a first column and label it shadow cost. This is where our shadow costs are going to go. So this part of the table here is exactly the same as this part. So just added a first row and a first column and labeled it shadow costs. Okay, so we're now ready to apply the algorithm. Now the way that this works is that we make the first source cost equal to 0. This column is going to have the source costs, the source cost for A, B and C, and this row here is going to have the destination costs W, X, Y and Z. Now we said that each cost, this 180, is made up of a source cost and a destination cost, and we're going to work out what these values are. And we start by making the first source cost equal to 0. So we'll put 0 in this column. And basically now we can almost like solve equations in a table. So basically if this is 0 and these two need to add up to 180, this top one here has to be 180. As we do this, the heading of the row and column need to add up to what's in the box. So 0 plus 180 is 180. So we go on to the next shadow cost. So if this is 0 and this heading need to add up to 110, that means that this one at the top is 110. So straightforward so far. And then we know that this heading up here and this value, those need to add up to 250. So if I've got 110 there and 250, this one has to be 140. So as we go along, just make sure that the total of your shadow costs equals what's in the box. So I've just put here, just make sure that the headings add up to what's in the cell rather than the box. Okay, so we've got 140 here, 150 there, 140 plus 10 is going to make 150. Okay, so it adds up to that. Then we move down to here, got 10 here, that's 190, so this has to be 180. And if I've got 180 there and 120 there, that means that I need to put 60 at the top here. Now, this is where we need to be careful, because you could put 60 in here and say, well, yeah, that's fine. But 180 plus 60 is 240. Shadow costs can be negative. Okay, shadow costs can be negative, so we need to be careful. So actually 180 minus 60 is going to give us 120, so there should be minus 60 up here. So be careful that you don't make that error in your working. And we found all the shadow costs and we can write them down. So the way that we write it is we'll use S to stand for source and D for destination. So the source cost at A is 0. The source cost at B is 140. And the source cost at C was 180. And our destination cost, so the destination cost from W was 180. So I'm writing down all the numbers in red. These are the shadow costs. The destination cost at X is 110. The destination cost for Y is 10. And the destination cost for Z is minus 60. Now you might say, well, how can a cost be minus 60? These are the costs relative to each other. So this basically means this cost here is 60 less than the others. So these how they relate to each other. The actual cost may be higher than this. So for example, if this cost at A, we made it 0, but if this cost, for example, was, let's say 100, then this is going to be 240, 280, 280. They're all relative to it. 210, 110, and then this would be 40. So these are like relative costs, not the actual costs. And these are what we call the shadow costs. Example 7. Calculate the shadow costs given by the initial solution of the problem given in example 3 shown in the table below. So we worked out the initial costs already in the example. If you need to watch it again, you can go back and do that. But I'm just going to put in the result of what we got, the actual initial solution. Right, so this is the complete table from that example. So this showed the initial solution using the Northwest method. So what we now do is transfer the costs associated with those into our shadow cost table. So our costs are going to be follow the same pattern in the same places. So we're just going to highlight those cells, the cost that we're going to be using. So those are these ones. So that includes a dummy as well. So those costs now go into our shadow cost table. So we have 9, 10, 8, 12, 8, 0. So remember, with this algorithm, I set the first source cost equal to 0. So I could write it like this. Source cost X is going to be 0. And then we use that to work out the other remaining shadow costs. Actually, I think I'll do this in red. Right, so I'll write these down. You don't need to do it. You can just write the actual values down. So that'll be source Z. Okay, so starting with 0 here, the heading of the row and column needs to add up to what's in the cell. So that means that this needs to be 9. So if 9 is that cell and this is 10, this one here needs to be 1. 1 plus 9 is 10. If this is 1 here, then the heading here needs to be 7. As you go along, make sure that you shouldn't be putting a negative down there. Be careful of that. So 1 plus 7 is 8. Since I've got 1 here, the heading here needs to be 11. Now, this is where we need to be careful. I've got 11 here. 11 plus what gives me 8? It'll be minus 3, negative 3. And if I've got negative 3 here and 0 here, that means that the heading here needs to be 3. So my shadow costs are for my sources 0 from X, 1 from Y, and negative 3 from Z. And my destination costs, shadow costs, from A, 9, B, 7, C, 11, and D, 3. Example 8, what I want to do is use the shadow costs found in example 6. So here's example 6, and here are the shadow costs that we calculated, as shown in the table above to calculate improvement indices and use these to identify the entering cell. So the first thing, what is meant by an improvement index? Well, we use some cells here in the northwest corner method. These are used cells, okay? We're only interested in the cells that haven't been used, so the ones that haven't been shaded in. So I'll highlight those in yellow. So we're going to do a calculation on these cells, and that calculation will give us something called the improvement index. And the way that we calculate an improvement index for any particular cell, which we write as I sub PQ, improvement index for PQ, is the cost of PQ, so that would be this number here, and we subtract the values of the shadow cost. So here I will do 190 minus 180 minus 140. For this cell, for example, I would do 240 minus 180 minus 180. So we are going to get negatives. 270 minus 110 minus 180. So we need to have calculated these shadow costs first, and then the cells that we haven't used in our northwest corner method, basically it's the cost minus the shadow cost. So the cost minus the shadow cost. So that's how we calculate the improvement index for these unused cells here. So the next thing we're going to talk about is what this entering cell means, and later on we're talking about exiting cell. Anyway, the entering cell is the cell with the most negative improvement index. Once we've worked out the improvement index, the cell that has the most negative value we call the entering cell. Now, if we have 2 or more cells to choose from, we can choose any of them. So if we have 2 cells that are both the most negative, we can choose either one. Doesn't really matter. And if there are no negative improvement indices, it means that we found an optimal solution. Now this is going to be important when we iterate this method and we want to know whether we found an optimal solution. That will be when we have no negative improvement indices. Okay, so let's now get this table ready to work out the improvement indices. Right, so I'm now going to put a cross in the cells where I don't need to work out the improvement indices, and it's the cells that have already been used. They're highlighted in blue in the table above. Okay, so these would have been the cells that I used in the northwest corner method. So that means that these other cells here have not been used. I'm going to calculate the improvement index. So let's start with this one here, the improvement index for BW. And now we could write that like this, I BW. And the calculation for that would be the actual cost of B to W, 190, minus the shadow costs, which are 140 and 180, basically the headings of that row and column. So I'll write it out for this one, but we don't need to write it out for the others. We'll just do the calculation. So 190 minus 140 minus 180, that's minus 130. The improvement index for this cell would be 240 minus 180 minus 180. That's negative 120. For this one here, improvement index for AY, so that would be, actually let's do this one first, improvement index for CX, which is this one, 270 minus 110 minus 180, so that's like 270 minus 290, so that's going to be negative 20. The improvement index for cell AY, so that's 130 minus 10 minus 0, so that's going to be 120. Improvement index for AZ, so this value here, so 290, and this is where we need to be careful. You subtract the shadow costs even if they're negative, so minus negative 60, so we're adding 60 to this, so that's 350, so watch out for that. And then last cell is going to be this one, 280 minus 140 minus 60, so that's basically 180 minus 140 plus 60, and that's going to leave us with a value of 200. So that completes finding the improvement indices. So two things that we can say from this table. First of all, since we have negative improvement indices, this solution is not optimal. Yeah, if they were none here, if they were all positive, we'd say we've got optimal solution, so we know it's not optimal. And the cell that has the most negative value is what we call the entering cell. So that's this one here. So we'll just write down entering cell is cell BW, since it has the lowest or the most negative improvement index. Example 9. Use the northwest corner method to find an initial solution to the transportation problem shown in the table. Now it's tempting to just dive straight in and work this out, but notice there's no total here. We do need to check whether or not the problem is balanced, because we may need to add a dummy. So I can see going across, this adds up to 40, and going down, this also adds up to 40. So the problem is balanced. I don't require a dummy. So do check that. If there's no total in that corner, do check it, because you could do all that working and then realize, or not realize, actually you need a dummy. Okay, so let's go. So X needs 10 units. So I'll put down 10 units. So it's got all that it needs. It hasn't used up all the supply of A. A has one left over, which we can supply to Y. Y needs 15, so it needs 14 more. There, okay, so this supply is used up. This supplier has 1 unit left. Y is happy, got everything he needs, so I'll put 1 unit there. This supplier has used up all. their demand. Z needs 14 more, which get from supplier C, so I'll put 14 there. So we can tick all of those. Our demand has been met by our supply. So this northwest method gives us an initial solution to the problem. So we're going to part B, and part B is asking us to find the shadow costs and then the improvement indices. So we'll start by finding the shadow costs. So for the shadow costs, we only need the cost of the cells that we've used. So I'll just highlight those in the original table. So that's AX, AY, BY, BZ, CZ. So we're going to put those costs in our table, which are 11, 12, 10, 13 and 9. So remember, with our shadow costs, we start by making the first source cost equal to 0. So I'll just rub these out so I've got a bit of space to do it. So my first source cost is 0, which means that this cost here is 11. That also means that if I have 0 here, then 12 needs to go up here. So 12. Now if I go down to this box, 12 plus something needs to give me 10. So that means that this has to be -2. Yeah. If this is -2 and I want 13, that means I need 15 up here. And if that is 15 here and I need 9, this needs to be -6. So I haven't labelled it as shadow costs, but these are my shadow costs here in red. So let's put shadow costs here. So now I work out my improvement indices. Improvement indices. So this table is going to look very similar to the shadow cost table. So X, Y, Z, A, B, C. And I'm only interested in the costs of the cells that I haven't used. So the cell that I have used, I'll just put a big X in them, big red X. So I'm interested in these. And remember what we do, we take the cost and we basically subtract the shadow costs. So for this cell here, BX, its cost was 13. And I do 13 minus the shadow costs. So I'm minus 11 and minus -2. So it's 13 minus 11 plus 2. That gives me a value of 4. The improvement index for this cell here, CX, 15. So CX is here. Let's actually put some circles in so I don't miss them out. And we'll just write down BX, CX, CY, AZ. Yes, and I'll highlight them here as well so I don't miss anything out. Okay, so yeah, the improvement index for CX is going to be 15 minus 11 minus -6. So 15 minus 11, which is 4, plus 6, that gives me 10. So we'll put 10 down there. The improvement index for CY, which is this one, 18 minus 12, which is 6, minus -6, so plus 6. So that's 6 plus 6, 12. And the last one, improvement index for AZ, 17 minus 15 minus 0 is going to be 2. And part C says, hence determine whether the solution is optimal. Well, it's optimal since I have no negative improvement indices. Okay, so the solution is optimal as there are no negative improvement indices. So you should now be able to do exercise 1C, which is just on page 18 of the textbook.